you're learning to handle factoring when it's got 4 parts. It's really not that hard. It's called factor by grouping. Do this one with me. Please write it down first of all. And now the trick to these is not, you just can't try to do it right off the bat with 2 sets of parentheses. It will end up looking like that when it's done, but you can't do that right off the bat. What you do instead is you break it into little parts. My dad was always good at, reminding me of this as I was growing up. You just can't get everything, like if you have a really big job, you just can't get it done all at once. You got to just do a little piece at a time and keep on knocking out the little pieces. Eventually you get done. We got to do that first part. See how I put that little red divider line in there? Think of it as 2 separate problems. The problem on the left and then the problem on the right. The problem on the left, I can factor that. That's easy. Well, how would I factor it?
So if it's over 4 terms in an equation, can you just split it into 2?
Yes, you can split it into 2 parts, just like this. So let's do the first part. What can I factor out of that first part? Yes, x squared. And when I do that, what do I have left? X plus 3. And now, on the second part, you can factor something out. 2 comes out of it. I'm going to call it positive 2 because it is. And what do I have left? X plus 3. And now, here's the part that takes a little brain stretch. You got to think about what you're really doing when you're factoring. When you're factoring, you're finding something that's in common in both things, and you're taking it out and putting it in front. Like here, we looked for what was in common in both of them, x squared was, and we took it out and we put it in front, and then we made a parenthesis, and we put what was left. Okay? So, what's in common now? X plus 3 is in common. So, that gets pulled out, brought up to the front, and what's left goes in parentheses here. See how this is going to go up to the front like this? And now what's left? That and that are left, so it's x squared plus 2. And now, if you feel like, wait a minute, that didn't make sense, how can I prove that I'm right? I just have to FOIL it out. Watch, firsts times that, what do firsts make? X to the third. And then after first, we do outside, then inside, then last, right? First, outside, inside, last. What's the outside ones make? Come on. 2x. The inside ones? 3x squared. The last ones? 6. And I'm going to put pluses in front of them. Does that look, even though it's in the wrong order, isn't that the same thing as what I started with? Therefore, they must be right. So I'm going to erase all the stuff I just did there. Get back to where the answer was, and it's right there. Okay. Just watching the first one, you're not likely to get good at it, but I want you to try this one. See if you can do it yourself. Some of you can handle this. I'll pause while you do it. Okay, so did you get this far? You see what's in common there, Gregerson? What is it? So that goes out front. And now what do I have left? Yeah? That is correct. Raise your hand if you had this. You're all wrong again. Yeah. All right. All right. Drew, tell me what to do. Yes, you caught it this time. X minus 3, x plus 3. Beautiful. There's your final answer. Okay? All right. So, then why am I doing this again? Because I can get the roots out of it. I'm going to write them in red so they stand out. Negative 2, positive 3, negative 3. I have 3 roots. They're all normal things. They don't have I in them, so they're all real numbers. And so, am I supposed to have 3 roots? Yeah, because if I look there, it tells me I'm going to have degree 3, so it has to have 3 roots. It all comes together. All right. Try another one. I think this is the last one. If most of you are fine, we will stop there and start your homework, which would be good. Okay, here's what I would have done. It's another one of these where I should divide it in 2 parts. X squared come out, x plus 3, and then What can factor out of that? Negative 8 can come out of that, and I'll have x plus 3, and ooh, it's in common. It comes out to the front, x plus 3, and then x squared minus 8 is left after these guys come up to the front. Remember, what you're really doing is, when you're factoring something out, is you're dividing by it. So really, I'm dividing by x plus 3, dividing by x plus 3, and seeing what I have left. You see how these cancel, and these cancel, and I end up with the x squared minus 8 left. All right, and some of you probably wanted to make sure that I wasn't burning you, and so you probably looked at this and decided whether or not you could factor it farther. Can you? No, you can't, because this is not a perfect square, and therefore it's not a difference of squares, and therefore your final answer is x plus 3, x squared minus 8. Raise your hand if you had that answer. And you're right this time. All right, good. So to finish this off, last piece we usually do is roots. How many roots should it have? 3 is correct. If it's got 3 roots, I can see one of them really easy. Negative 3 is a real root, and it's easy. Think carefully. Is that going to be, it's 2 roots. Is it imaginary? How can you tell if they're imaginary or not? The way you tell is by writing out x squared minus 8 has to equal 0, and then solve it. Everybody, right now, solve that. It'll just take you 2 seconds, and you'll know whether it's imaginary or not. So what's your first step? Hey, some of you aren't doing this. I want you to actually do this on paper right now. Solve that. These are real roots because we don't have a negative underneath that square root. But if you left it this way, you'd be wrong. Why? Split it up into 4 and 2. You're right. X equals plus or minus square root of 4, square root of 2, which is really x equals plus or minus 2 root 2. All right. So those are the 2 harder roots to find. The easier one is right here. And so I have 3 roots, which matches up with this 3 right here. It all comes together in perfect harmony.